Numerical solutions. Many equations cannot be solved exactly, but various methods of finding approximate numerical solutions exist. The most commonly used methods have two main parts, which are finding an initial approximate value and improving this value by an iterative process. So what is initial values? The initial value of the roots of fx equal to 0 can be located approximately by either a graphical or numerical method. So this is how we use graphical method. So if you are given one function, let's say y equal to fx, the real roots are at the points where the curve cuts the x-axis. Or if you are given two functions, let's say y equal to fx and y equal to dx, the real roots are at the points of intersection between two graphs. So for example, find the roots of the equation y equal to x cubed by using the graphical method. So as we know earlier, we have to sketch the graph first. So we have to sketch a cubic graph. So we have the basic graph of cubic here. And as we know that the real roots are the points where the curve cuts the x-axis. The curve cuts the x-axis at x equal to 0. So we can write the conclusion, the root is x equal to 0.
Next, sign change method. First of all, find two values of a and b such that fa and fb have different sign. Next, at least one root must lie between a and b if fx is continuous. For an example, show that the equation 3 power of x equal to x power of 3 lies in the interval x equal to 2.4 and x equal to 2.5. Substitute the value of x in the equation, which is f 2.4, and we get the answer 0.1, which is greater than 1 and it is positive. And then f 2.5, substitute in the equation and we get negative 0.04, which is less than 0 and it is negative. Thus, since there is a sign change between x equal to 2.4 and x equal to 2.5, there is a sign root. So, these are the steps that you have to follow to solve the Newton-Raphson method. So, the first step is to find fx and f prime x. So, the second step is to choose a first approximation x0 to the root of the equation. Step 3 is the iteration, which is this formula you have to memorize, which is Sn plus 1 equal to Sn minus fxn over f prime xn. There are two things that you have to take note when you use Newton-Raphson method. The first one is two steps of substitution must be shown, and the second one is the work step must have extra decimal places. Example, by using the Newton-Raphson method, find the solution of fx equal to x plus exponent x near x equal to negative 0.5 to 4 decimal places. So the first step, we know that we have to find fx and f prime x. So fx is given in the equation, we have fx equal to x plus exponent x. So now we need to find f prime x, so we have f prime x equal to, we'll just differentiate the function, differentiate x will get 1, differentiate exponent x will get exponent x. So this is the step 1. So step 2 is you have to find your initial value here. So choose a first approximation x0. So here it is given in the equation x0 equal to negative 0.5. So we will have x0 equal to negative 0.5. Step 3 is to use the formula of Newton-Raphson method. So we have Sn plus 1 equal to Sn minus fx over f prime x. So our fx is x plus exponent x. So we will have Sn plus exponent Sn over f prime x. So this is our f prime x. We will have 1 plus exponent Sn. So now we just substitute the value of our initial value into this Sn here. So we will get, so Sn plus 1, our initial value here is 0. So 0 plus 1 you will get S1 here equal to, so this is negative 0.5. So we just substitute the value 0.5 minus 0 negative 0.5 plus exponent negative 0.5 over 1 plus exponent negative 0.5. So just press your calculator, you will get the answer, which is negative 0.5663. So please take note, the equation has 2 4 decimal places. As I said before, we have the working step must have extra 1 decimal places. So in this question, you have to give your answer in working step 5 decimal places. So we'll have 56631. So we just continue. So this will be our next value of x. So we will have x2 equal to negative 0.56631 minus negative 0.56631 plus exponent negative 0.56631 over 1 plus exponent negative 0.56631. Again, press the calculator and you will get the answer measured in 5 decimal places, because the question asks for the 4 decimal places. We give extra 1. So here you get negative 0.56714. Now this is the first substitution and this is the second substitution.
So your working step is the first two substitution must be shown. So x3, let's say for x3 you can just press your calculator, so you don't need to show your substitution, and you get the answer negative 0.56714. As you can see here, the answer for x2 and x3 is the same, so we call this as stopping criteria. That means we have to repeat the process of iteration until the answer agrees with specific number of decimal places. As you can see here, x2 we get negative 0.56714, and x3 we get negative 0.5610, same as x2. So we can stop here and conclude the answer as x equal to negative 0.56714.